So the question is, what happens when you enter a URL into a web browser and hit enter? Explained with as much technical detail as humanly possible. Firstly, when you press enter on your keyboard, a circuit is completed which sends an electrical signal to the keyboard's microcontroller. The microcontroller then processes this signal and sends a corresponding signal to the computer's central processing unit, CPU, indicating that the enter key has been pressed. The keyboard circuitry includes a key matrix, which is a grid of rows and columns, with each key corresponding to a unique intersection of a row and a column. When you press a key, it completes a circuit between the row and column corresponding to that key, seen in this figure, sending an electrical signal to the keyboard's microcontroller. The microcontroller then translates that signal into a corresponding scan code or character code, as an example, intersection C3, which is sent to the computer's CPU via the keyboard's interface, which is like a USB or PS2. Or if you are on a laptop, through wiring of the motherboard. The CPU then interprets C3 as the enter key being pressed and sends those commands up to your operating system and creates an event. When you press the enter key in a web browser, the browser receives the event generated by the operating system, and the browser's rendering engine handles that event. The browser's rendering engine listens for the key down event, which is triggered when a key is pressed down. The browser then sends an event to the web page indicating that the enter key has been pressed. The web page can listen for this event using JavaScript to perform some action, such as performing a search. For example, if you are on a web page with a search box, pressing enter will trigger the submit event for the search form, and the browser will send a DNS query immediately following you hitting the enter key. After the browser's event handler interprets the enter key and reads the URL, the Uniform Resource Locator, your browser uses a DNS, Domain Name System Server, to resolve the domain in the URL to an IP address. This process first starts by checking your browser's local DNS cache to see if it's already visited the web page, and if it has a copy of it. If it is not cached, the browser sends a DNS query to a DNS server. The DNS server responds with an IP address associated with the domain name. If no result is found in the DNS resolver, then it asks the name server listed above the first DNS server in the hierarchy until it finds a result. Assuming it finds the correct IP address, it then caches that address locally, and the browser initiates a TCP connection to the web server at the IP address it obtained. The browser then sends an HTTP request to the web server, including the domain name, requested resource, and any additional information such as cookies and headers. The web server responds with an HTTP response, including the requested resource, HTTP headers, and any additional information such as cookies or data. The browser receives the HTTP request and renders the web page, including any HTML, CSS, JavaScript, or any other relevant content. In most modern browsers, you would get a security warning, as any data that transmits to and from the website this way is not encrypted and can be vulnerable. To fix this, engineers implement a more secure protocol called HTTPS. When you type in a URL in your web browser and the website is secured with HTTPS, the process is similar to an HTTP request as discussed earlier, but with additional steps for establishing a more secure connection between the browser and the server. Firstly, the web browser sends a DNS query to a DNS server and resolves the domain name in the URL to obtain an IP address. The browser initiates a TCP connection to the web server. A TCP handshake starts with the client sending a SYN packet to the server to initiate the connection. The server responds with a SYN-ACK packet to acknowledge the request and initiate a connection. The client responds with an ACK packet to confirm that the connection has been established. Then the browser sends a TLS, a Transport Layer Security Handshake, message to the web server to initiate a secure connection, commonly called a client hello. The message includes the supported TLS versions, cipher suites, and random values. The web server responds with a TLS handshake response message that includes its SSL and TLS certificate, which includes a public key, domain name, and other information, called the server hello. The browser verifies the SSL TLS certificate to ensure it is issued by a trusted certificate authority and the domain name matches the server domain name. The browser then sends a finished message to indicate that it is complete its part of the handshake, and the server does the same. The browser and server now have shared symmetric key, which is used to encrypt and decrypt all data exchanged between them in an HTTPS session. From there, the browser sends an HTTPS request to the server, including the domain name, requested resource such as a web page, and any additional information such as cookies or headers. The web server responds, and once the HTTPS response has been received, the browser and server close the HTTPS session. The encryption type is defined in HTTPS by use of cipher suites, which in more detail is a combination of cryptographic algorithms that are used to secure a connection between clients and servers. When establishing a secure connection using protocols such as HTTPS, the client and server agree on a cipher suite and will be used to encrypt and decrypt the exchange during a session. On average, a cipher suite will consist of all or more of the following components: a key exchange algorithm. This algorithm is used to securely exchange cryptographic keys between the client and server. Examples include Diffie-Hellman and elliptic curve Diffie-Hellman. An encryption algorithm. The algorithm is used to encrypt data transmitted between the client and server. Examples of this include the AES standard or Triple Data Encryption Standard 3DES. And RC4. Message Authentication Code or MAC algorithm. This algorithm is used to ensure the integrity of data transmitted between the client and server. Examples here include hash-based message authentication code, HMAC, and cipher-based message authentication code, CMAC. And lastly, the protocol version. This specifies the version of protocol being used, such as TLS 1.2 or TLS 1.3. Arguably, most important to the cipher suite is the key exchange. When you do this over the internet, you have to take into account that the encryption agreement is established in public. So how do we do this without giving away any secrets? Let's take a closer look at the Diffie-Hellman key exchange algorithm. The Diffie-Hellman key exchange is a method for two parties to agree on a shared secret over an insecure communication channel, without ever exchanging the key directly. The method is based on the difficulty of computing discrete logarithms in a finite field, and works as follows. Alice and Bob agree on a large prime number, P, and a generator, G, where G is a primitive root of modulo P. Alice chooses a random secret integer, A, and computes A equals G over A mod P. She sends A to Bob. Bob also chooses a random secret integer, B, and then computes B equals G over B mod P, and he sends B to Alice. Alice computes S equals B over A mod P, which equals to G over B mod P over A mod P. And Bob computes the same in the reverse. S equals A over B mod P, which is equal to G over A mod P over B mod P. Now Alice and Bob have both the same shared secret keys, S equals 2, which they can both use for symmetric encryption. Therefore, an eavesdropper who intercepts the message exchanged between Alice and Bob would not be able to compute the shared secret key without solving this discrete logarithmic problem. At this point, the connection is established, and the client and server can exchange data using the agreed-upon cipher suite. The encryption and MAC algorithms specified in the cipher suite are used to ensure that the data exchange between the client and server is secure and protected from interception or snooping, and the user may begin browsing the various web pages offered by the website hosting server. And that is what happens when you enter a URL into a web browser and you hit enter. If you are interested in the documentation on this subject, I have put everything I've said here on my GitHub, link is in the bio.